Good morning, guys. Welcome back. Welcome back. So we're actually kind of in the middle of this chapter. So we're talking about triangles, and I don't know if you guys remember. Do you remember what all the angles in a triangle add up to?
180.
180. Good. Okay, so all the angles in a triangle add up to 180. We also talked about acute triangles, right triangles, equilateral triangles, isosceles triangles, scalene, and all that. So now we're starting to prove that triangles are congruent. So this is the very beginning of proving that triangles are congruent. I actually really like this stuff. So tomorrow is a worksheet. Today is online. So we're going to start proving that triangles are congruent by the definition of congruent triangles. Are you super excited to be back at school?
Yeah.
Sure.
No?
Let's go.
Okay, congruent means two figures are the exact same size and shape. They look identical. They're like twins. The exact same size and shape. That is what congruent means. So we're going to start by proving that triangles are congruent. The statement is very, very important. Good morning. Statement is very important. So this says triangle ABC is congruent to triangle XYZ. You guys are going to be focusing on that statement today. So like, for example, if I look at angle A, notice that's the first letter in the statement. What's the first letter in the other?
X.
So that means that angle A is congruent to angle X. So corresponding parts of congruent triangles always equal each other. So angle A would equal angle X. What do you think angle B would equal?
Angle Y.
Angle Y. And yeah, you can see it on the picture, but sometimes the triangles are turned and it's harder to tell. Always look at the statement. Always look at the statement. So angle C would be congruent to angle Z. Okay, so we can name angles with one letter. We're going to name sides with two letters. So if I said side AB, see how that's the first two letters? What do you think that would be congruent to? Side XY. So always look at the statement. So side BC, last two letters would be congruent to side YZ. And side AC, first and last letter, would be congruent to XZ, first and last letter. Whoa. Okay, so let's try to name some corresponding parts. So again, you can probably tell by the pictures because the triangles look the same, but sometimes the triangles are turned. So always look at the statement. Triangle BAD, B-A-D, is congruent to triangle the. So angle B, which is the first letter, would be congruent to angle T. Angle A would be congruent to angle H, and angle D congruent to angle E. Not bad at all. We name sides with two letters. So BA, first two letters, would be congruent to TH. AD congruent to, and then BD, first and last letter, TE. Okay, how do you feel about that?
Tired.
Tired? Would you be able to do that on the assignment?
Yeah.
Good. Okay, you'll have just a couple problems where you have to solve for the variable. It's not going to be hard, so I didn't set out calculators. If you need a calculator, I'll set them out. So this says find A. So up here it says quadrilateral JIHK is congruent to QRST. So A, notice what is where side HI is. So HI is those middle two letters. So what side would that be congruent to on the other? RS, which is 6. So I know that 3A equals 6. What would A equal?
2.
A would equal 2. That's not bad, is it? And so the algebra is going to be like that today. It's not going to be hard. So let's find B. So B is angle H. H is the third letter. What would that be congruent to?
S.
S, which is 120. So 4B equals 120. Divide by 4. What would B equal?
30.
30. Are you guys still asleep?
Yes.
Yes. Okay, and then last but not least, let's find C. So C is where angle T is, and T is the last letter. So that would be congruent to K, which is 30. So C plus 10 equals 30. What would C be? 20. Okay. Last thing we need to talk about is proofs. So we're going to start having proofs by proving that triangles are congruent. So we have this third angles theorem, and you're going to use that in your proofs today. So all the third angles theorem says is if you have two angles in one triangle, and they're congruent to two angles in another, then those third angles have to equal each other. But think about it. What do all the angles in a triangle add up to?
180.
180. So if you know that this is 50 and 50 and this is 60 and 60, if you do 180 minus 50 and 60, like when you have to get the same thing on both, so those third angles have to equal each other. So that's called the third angles theorem. You will have that in your assignment today, third angles theorem. So let's practice a couple proofs and then we'll look at your assignment. Okay, so in order to prove that triangles are congruent, you have to prove that all three angles in one triangle equal all three angles in the other, and all three sides in one triangle equal all three sides in another, and that's the definition of congruent triangles. So I have some given, and I'm just going to start with my sides. So I've got QN congruent to OP. Notice they're marked with the slashy marks. You guys remember that? And then QP and ON are congruent. So notice that's up here with the given. I have given. Do you see how there's more given here?
Yo.
But that's down here in line 3. Okay, so I'm going to start with my sides, though, because all three sides of one triangle have to equal all three sides of the other. So if I look at this triangle and then this triangle, do you see how they have side NP in common?
Yeah.
So I don't know if you remember this property, the reflexive property, but that's when something equals itself. So I'm going to say that NP equals NP. It equals itself. So now I have all three sides and all three sides. Now I've got to look at my angles. So I'm given that angle Q is congruent to angle O. Marked it with the humps. I'm given that NPQ is congruent to PNO. So now, why would those third angles have to equal each other?
Because the third angle equals the third angle.
So that's called the third angle theorem. Third angle theorem. So you're going to have that today. So now that we have all three sides equal to all three sides and all three angles equal to all three angles, you can say that the triangles are congruent by definition of congruent triangles. Is it too early to think about proving triangles are congruent? No.
Okay.
Too late.
So you will have third angles theorem today. You'll have definition of congruent triangles. So let's try one more. So I'm given that angle L is congruent to angle P. That's already marked with the humps. And I'm given all three sides. All three sides. So that is given. Okay. Well, all I'm given is one angle. So I've got all three sides. I need two more angles. But what do we know about these two angles?
They're the same.
Vertical.
They are vertical angles, so they equal each other. So I need to name these two angles, and I'm going to name them with 3 letters because I can't just say angle N because they're connected. How could I name this angle? L and M is congruent to
O and P.
O and P. Does everybody see that? And those are vertical angles, so now I have all 3 sides and 2 of the angles. How do I get that last angle? What's that called? The what angles theorem? Third angles theorem. And since those angles are all lonesome by themselves, I can name them with 1 letter. So I could say angle M is congruent to angle O. Why could I not do that here? Why could I not just say angle N equals?
Because they've already.
Okay, because it's connected to another angle. So do you see the difference how M is way over here by itself? So I could say, okay. Okay, and then finally, since I have all 3 angles and all 3 sides, I can say the triangles are congruent by definition of congruent triangles. So my joke today is probably kind of lame. I think it's disappointing, but it says yesterday at 8 o'clock it was very time consuming, especially when I went back for seconds. Okay, is that dumb? This one is good though. This one's good. I need to pull this up. So there are 2 snowmen. The snowman's like, brrr! That's pretty funny.
I don't get it.
Yeah.
These rubbing two sticks together.
That's how that works.
All right, I need to unlock this for you guys, probably, huh?
Supposedly, like, if you
Let
root
me
2, 6,
unlock.
like,
I still
the
don't get it.
friction comes
I don't
in
get it,
five.
Jake. I don't get it.
This one.
Yeah, I tried selecting it.
I go,
Also,
Also, nice
Yeah.
voice here now, dude.
2 days.
How does
Explain.
Hey, that's.
All right, it should be unlocked. So hit
I
refresh.
didn't know that it was gonna be that bad.
Should be
I actually didn't
unlocked.
listen to it. Of course, that's not a girl.
That's a guy next to the
Nobody does.
That's not. Okay, for question 1, remember always look at the statement. The statement rather than the picture because those triangles are flipped and it's kind of hard to tell. So always, always, always look at the statement. Pay attention to the order too because that's how I have the answers in here. So KJ, notice is the last letter and then the middle letter. Do you guys see that?
Yeah.
What would that be congruent to?
CN.
CN. So do the right order also and put capitals there. Capital. So JB is middle first. What would that be? ML, good. Angle L would be congruent to angle B.
MLB.
And M would be congruent to J. Okay, so now you've got the triangle congruent statements. The order matters. Order matters. So CML goes last, middle, first.
KJB.
KJB. And then JKB. Good. MCL. So order does matter. You have to make sure you match your correct corresponding parts. Again, pay attention to the statement. It's so much easier to look at the statement rather than the picture because the triangles can be flipped. Okay, let's see. So you'll have to do the same thing for question 2 and question 3. So question 4, let's look at question 4. We have to make sure we line up correct corresponding parts. So if I look at BCD, notice if I go from B to C, see how I'm going over that line with the slash? And I'm going to the right angle, and then I go over to D, which is that vertical angle. Make sure you match corresponding parts. What would it be congruent to on the other triangle? Yeah, NMD. Does that make sense? So if I start with B and then go to the right angle, I have to start with N and then go to the right angle. So NMD.
NMDR1.
Okay, so make sure when you match up corresponding parts that it's in the correct order. So you'll do the same thing with 5. 6, you're just filling in the blanks again. Do you guys see how these blanks work? So A would go here. Okay, let's see. Maybe let's look at one of these. Let's look at 9. Doesn't matter. Question 9 says triangle ACB is congruent to triangle JKL. Which of the following must be true? So again, I'm not going to even look at the picture. I'm going to look at the statement. So angle A is congruent to angle L. Is that true? No, because that's first letter and the other one's last letter. Does not work. B and K, would that be true?
Yes.
B is the last letter, K is the middle letter.
Oh.
Yo.
So what about AB? AB is first and last letter. JL, first and last letter.
It do be kind of true.
So which one would it be?
B.
B. Okay, good.
No, D.
You will have a little bit, make sure you match your correct corresponding parts. What I want for questions 10 and 11 is I want the actual length. So like here on question 10 where it says find the length of AB, well I know that's congruent. AB is congruent to DE, but I want the actual length. So what is that length?
3.5.
3.5. And you don't have to put millimeters. And then angle E, well, B is the middle letter and it's 90, so what would angle E have to be?
90.
90, yeah. So I want the actual length. Don't forget that all the angles in a triangle have to add up to 180 in case you have to find. All right. Anything else? You have a little bit of algebra. If you need help setting up, let me know. You've got a couple proofs. You want me to do one of these with you?
Yeah.
Let's do 17 because it's actually fill in the blank. Because 16, you got the drop down. Hopefully you can do it. So 17, it says angle A is congruent to angle D. What would that be? Given, good. So given angle A is congruent to angle D. I'm also given up here that AE is congruent to DC, EB congruent to CB, and B. Do you guys see that? Where's the other given at on this proof?
No.
4.
Number 4. So I'll go ahead and put given there. Notice all the given doesn't always have to be at the beginning. So our ultimate goal is to prove that all 3 angles equal all 3 angles and all 3 sides equal all 3 sides. So let's look at ABE and DBC. Why would these 2 angles be equal to each other? Vertical, yeah. I think I put there's a space. Vertical angles. Can you spell vertical correctly? It's not LE.
CAL.
Vertical, yeah, CAL. Vertical angles.
Capital C is just little C.
I don't think you have to have capitals, and I'll double check before you hit submit. Don't submit. I'll double check the answers. Okay, so then if I have 2 sets of angles, why are those other angles equal to each other? What was that theorem called?
Third.
Third, yeah. And I don't. Yeah, go ahead and write out third just in case.
3 already.
And then, yeah, I'll have to look if I have 3 RD. I don't know if I do. And then, since I have all 3 angles and all 3 sides, I can finally say that the triangles are congruent by definition of
Congruent.
congruent triangles. Congruent triangles. Plural. Triangles.
Sheesh.
TRIANGLES.
TRIANGLES, yeah.
CLNGRUENT.
All right, that is it. Tomorrow we actually have a worksheet and we're going to be proving triangles are congruent.